Hello everyone. I'm audible. Hello everyone. I'm audible. I'm audible, guys. Good evening, everyone. Good evening. Quickly tell me in the chat. Am I audible, guys? Hello everyone. Good evening. So we'll be starting the day 3 of this bootcamp in 2 to 3 minutes, so that everyone can join. So have you guys attended yesterday's session, like the day 1 and the day 2 of this bootcamp? How many of you attended the yesterday's session? How many of you attended yesterday's session? So yes, many of you guys have attended yesterday's session. Great. Yes. So guys, most of you have attended both of the days. Great. Great. So in today's session, we will be starting with the ML models. Okay. We will be seeing the mathematical intuition behind one of the most famous machine learning model, that is linear regression model. Great. So let's start with a little bit of revision of yesterday's session, okay, so that everyone can join till then. So in yesterday's session, we have discussed about the 3 Python libraries, that is NumPy, Pandas, and Matplotlib, right? Certificates will be distributed at the end of this bootcamp. Okay, after all the 5 days, then the certificates will be published and distributed among you guys. Notes for the session are available in the community description. So there is a link provided in the community description. You can just visit that link and you will get all the notes, all the coding files, and all the data sets and everything. Okay. So the project will be the house price prediction project, in which we will create the proper, first we will train the model. Secondly, we will create the proper front end and back end using the Flask, or we'll see Fast API or anything. Okay. So the project will be a house price predictor. The certificates will be issued after all the sessions. Okay. If you have missed yesterday's session, don't worry. Just attend the rest of the 3 classes and mark the attendance positively. Okay. The attendance link will be shared at the end of the session. The project will be the house price predictor. Okay. And if you don't understand any of the library, the video is on the YouTube. You can just go and visit the DevTown channel and watch the video again. Okay. Okay. So it's time to start the session. Start today's session. So first of all, let me just share my screen quickly. Okay, so is my screen visible, guys? Just quickly tell me, is my screen visible, guys? Guys, quickly tell me, is my screen visible? Yes, so my screen is visible now. Great. So let's just begin with today's session. So in today's session, we will be going to cover the topic that is linear regression. Okay, so I will start from the basic. So first of all, machine learning. Okay, first of all, let's talk about machine learning. Okay, sir. Very basic thing from the word machine learning, we can say that when the machine learns on itself and gives us some kind of output, we call it machine learning. Okay, sir. Sir, what are the types of machine learning then? There are basically three types of machine learning. That is supervised. The second one is unsupervised. And the third one is reinforcement. Okay, so we have discussed the basic definition of supervised and unsupervised. Okay, we haven't discussed reinforcement because it comes in the kind of advanced portion of machine learning. Okay, so under supervised, we have two types, that is classification and regression. Okay, sir. Sir, what is classification? Sir, what is classification? Classification is when we are going to predict any of the class. Suppose I am saying true or false, or I am saying male or female. Okay, so we are predicting some kind of class. Suppose we are saying apple or banana. So we are predicting one of the class. Okay, so whenever we are trying to predict any discrete value or a class, we call it classification. Then, sir, what is regression? When we are predicting any continuous value. Okay, when we are predicting any continuous value. Sir, what do you mean by continuous value over here? For example, suppose I am saying salary of a person. Okay, the salary of a person can be anything like 10k, 12k, 15k, and any value. Okay, 15.5k, 15.7k. The salary can be anything. Suppose if I am taking one more example as age of a person. Age can be any value. 5-year-old, 10-year-old, 12-year-old, 13-year-old, 14-year-old, any value. Okay. So when we are predicting such kind of continuous values, we call it regression. Is this clear, guys? The basic definition of classification and regression. The basic definition of classification and regression is clear, guys. So this is what we have discussed in the day one of this bootcamp as well. Okay. Great. So this is clear first of all. Okay, sir. Sir, you have told us about many algorithms, right? Yes. So many algorithms are there under machine learning, that is supervised learning. Okay. Some of the algorithms are logistic regression. Okay, sir. Any other algorithm? Yes. Linear regression. Okay, sir. Sir, any other algorithm? Yes. We can say SVM, that is support vector machine. Any other algorithm, sir? Yes, that is random forest. And there are many more algorithms. Okay, we can discuss all. But it's not like each and every algorithm is applicable on each and every type. Like this logistic regression. This is a classification algorithm. Like we can only apply this logistic regression in classification problems, like when we have to predict a class, like apple or banana, male or female, and everything. But sir, it's written regression over here. Yes, it is written regression. It is logistic regression. Still, it is used for classification problems. Okay, sir. Sir, this linear regression over here. Yes, this is a regression problem. This is a regression problem. Okay, sir. Then, sir, this SVM, that is support vector machine, this is a classification problem or a regression. Quickly tell me, guys. Support vector machine is used for classification or regression. Anyone of you have any kind of idea? SVM is used as a classifier or a regressor. Okay, some of you are saying regression and some of you are saying classification. Yes, so the correct answer is it can be used as both. So what do you mean by both? We can use support vector machine as both classifier and regressor. Sir, is this possible? Yes, this is possible that we use support vector machine as both classifier and regressor. Okay, sir. Sir, what about random forest? Same case for this. It can also be used as both classifier and regressor. Okay, sir. Sir, what is the project that we are going to make? At the end of this bootcamp, sir, what is the project that we are going to make? So the project that we are going to make is house price predictor. Okay, sir. Sir, what do you mean by house price predictor? That you will just give some kind of values that these are the number of bedrooms and this is the like area of the house and something, and it will give you the price of the house. Okay. So okay, sir, this will be our project. Then, sir, the house price. If you will focus over here, house price. House price can be any value, right? Yes, you can. Yes, Gaurav, you can add this project as a basic ML project. Okay. Like this cannot be come under a major project, but this can surely be come under a minor project as a, you can say, machine learning project. Okay, great. So next thing, yes. Sir, we are going to predict the house price. Okay, sir. Sir, house price, the value can be anything. Suppose I am saying 10K or 20K or 15K or 35K or say 35.5K. So the house price can be any value, right? There is no fixed value in house price, we can say. Okay, so value of house price can be any value, right? So this project, this house price predictor, lies under regression. What we have learned, sir, that whenever there is a case in which we have to predict a continuous value, we call it regression. Is this clear? So the project that we are going to make comes under regression model, or we can say we are going to make a regression model for our project. Is this clear, guys? No, house price prediction is not your assignment. We are going to make that project live on the day 3 and day 4. Oh, sorry, day 4 and day 5. In day 3, we will be seeing the mathematical intuition behind the model. No, it is not compulsory that you have to use the Flask. I am going to use Flask for the front end part only. Okay. It's not like you always have to use Flask or anything. So till now everything is clear, guys. Quickly write clear in chat if everything is clear. Quickly write clear in the chat. Okay. Come on, guys. Great. So everything is clear till now. Great, sir. So this much is clear that we have to make a regression model. Okay, sir. Sir, you have told us some algorithms. Yes. The algorithms are logistic regression, linear regression, SVM, random forest, and many more. Sir, what is the very basic algorithm for regression? So the very first algorithm or very basic algorithm for regression is this linear regression over here. Okay, sir. So we are going to train our model based on linear regression. Like I will try to show you the model based on these two or any of other models. But today we are going to do the mathematical intuition behind linear regression. So why linear regression only? Because we can say it is easier to understand the linear regression mathematical intuition as compared to all the others. Okay. So we are going to use linear regression. In today's session, we will be seeing the mathematical intuition behind linear regression. And in tomorrow's session, we will be applying the linear regression on our data set. And we will be making the model. Okay, I will surely show you the random forest as well in the implementation session. Okay, great. So let's begin with linear regression. Let's begin with linear regression. So, sir, linear regression. We can clearly see two words here, linear and regression. So, what do we mean by linear? Linear is straight. Okay, linear is straight. And sir, what do we mean by regression over here? Regression is when we predict a continuous value. When we predict a continuous value. Okay, sir. So linear means straight and regression means when we predict a continuous value. Okay, sir. Sir, what can we understand with this linear regression now? So first of all, let's discuss the aim of linear regression. So what is the aim of linear regression? So the aim is to find the best fit line. To find the best fit line. So what is best fit line? I will explain you in a while. Okay. To find the best fit line with minimal residual error. With minimal residual error. Sir, what do you mean by best fit line over here? Or what do you mean by minimal residual error over here? Okay, let me just take an example. Suppose I have a data set. Okay. Attendance will be done at the end of the session. So please try to focus and concentrate on the session right now. Okay. So yes, let me just take an example. Suppose I have a data set with two columns. The first one is year of experience and the second one is salary. Okay, the first one is year of experience and the second one is salary. Suppose a person have year of experience say 1.5 years. Okay, his salary is suppose 10,000. So salary in thousands. Okay, suppose his salary is 10,000. Okay, sir. Suppose the year of experience is 2 years and the salary is 15,000. Suppose the year of experience is 0.5, the salary is 5,000. And similarly, I will take values like 5 years and the salary is 25k. The year of experience is 4 and the salary is say 30k. Okay. So this is a, we can say, data set we have in which I have year of experience and the salary of a person. Is this clear? I am taking this example. Okay, sir. What if I try to what if I try to plot this data on a graph? Okay, sir, this is my graph and my data is like, suppose if the year of experience is 1.5 and the salary is 10, so I'm going to plot it somewhat here. Suppose the year of experience is 2 and the salary is 15, I'm going to plot it somewhat here. And like respectively all the values are like this. Okay, so I'm plotting it randomly. So these are all the values if I plot it. Okay. Okay, sir. Now what will I do? I will try to, while applying linear regression, what will I try to do? I will try to make a line. I will try to make a line that will cross most of these points. Okay, I will try to make a line, a straight line that will cross most of these points. Okay, sir. This line will be my best fit line. Okay, sir. But sir, as you can see, this value, this x over here is not aligning with these lines. Okay, sir. These x's or these points are not aligning with the line. So what is the difference? Sir, this is the difference among the line and the points. Sir, this is the difference among the line and the points. So this difference over here will be my residual error. This difference over here will be my residual error. So we have covered the two terms, that is the best fit line and residual error. So again we will read the aim. So the aim says that to find the best fit line with minimal residual error, so that this residual error over here will be minimum. Okay, we have to find the best fit line with minimal residual error. Is this clear, guys? Is this clear, guys? The aim of the linear regression, is this clear? No, I am taking this graph just for the we can say like for the example only, for teaching purpose only. Okay, not like each and every time you want to train a model you are going to create a graph. It is not like that. Okay, so till now everything is clear. Great, sir. Sir, we understood the aim, that we have to make a best fit line with minimal residual error. Okay, sir. So what is best fit line? The line that crosses through like most of the points, that is our best fit line. And sir, what is the residual error? The error between the points and the line, best fit line, is called the residual error. Okay, sir. Now I will ask you a question. Okay, just quickly reply to my question, okay, in the chat. My question is, what is the equation of line? Okay, quickly reply to this question. Quickly reply the answer in the chat. What is the equation of line? What is the equation of a line? Yes, great, 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 great. So all of you have answered it correctly. The equation of line is y is equal to mx plus c. Okay, sir. Sir, what is this y over here? This y is the predicted value. The y is the predicted value. Okay, sir. Sir, what is this x over here? X is the input value. Okay, sir. Sir, what is this m over here? M represents the slope. M represents the slope. Okay, sir. Sir, what is this c over here? This c is the intercept. Okay, sir. So I hope all of these basic terms you already know, like what is the slope, what is the intercept and everything. So I will quickly tell you once again what is the slope and intercept and everything. Suppose I have a graph over here. Okay. and a line passes through this. So the angle over here will be our slope. Okay. Suppose I have one more line that passes through this. Okay. So the distance over here, like suppose this distance is 1, so this will be our intercept. Okay, so the distance from the from the x-axis on the y-axis is the intercept, and the angle that is made is, we can say, the slope. Okay, if the line is like this, the slope is positive. Suppose if the line is like this, the slope is negative. Okay, sir. Okay, sir. So the equation of line is y equal to mx plus c. Okay, sir, this is clear to us. Now, sir, what I am going to do, I am going to just write, I am going to write this y as h theta x. Okay, let's leave this. I will just keep it as y. Okay, because most of the times whenever you are going to search on Google as well or any other area, you will be going to find that the equation of line in linear regression is written as h theta x equal to theta 0 plus theta 1 x1. Okay, so what is this h theta x? H theta x is nothing plus y, nothing but equal to y. Theta 0 is the intercept, theta 1 is the slope, or we can say m, and x1 is the input value. Okay, so most of the times this is how we write the equation of line, but we will be considering this equation only. Okay, is this clear, guys? Is this clear, guys? Quickly write clear in the chat if everything is clear. Great. So this much is clear. Okay, sir. Sir, what if, let's take an example. Suppose, let's say this is a graph. Okay, sir. Suppose I am going to take some values as 1, 2, 3, and again 1, 2, 3. Okay, sir. Suppose I am taking theta 0, or instead of theta 0, I am taking it c. Okay. Suppose c is equal to 0 and sorry, c is equal to 1.5 and m is equal to 0. So my slope is 0 and my c, that is intercept, is 1.5. So I will have a line like this. Okay, in this line the c over here is 1.5 and the slope is 0. Okay, sir. Sir, can you explain us with one more example? Sure. Suppose I am taking c as 0 and say I will take slope as 0.5. Okay, this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. So I will have a line like this, where this one will meet at 0.5, this is 0.5. Okay, then this 2 will meet at 1 and this 3 will meet at 1.5. Okay, so these are some of the examples with respect to the intercept and the slope. Okay, sir. Now, sir, you told us about the aim that, sir, the aim is that we have to find a best fit line with minimal residual error. Okay, sir. But, sir, how to find the best fit line? Sir, how to get the best fit line first of all? So to get the best fit line, we will be defining a cost function. So what do you just said? We will define a cost function. We will define a cost function to get the best fit line. Okay, sir. Sir, in this line over here, in this sentence, we know what is the best fit line. But sir, what is this cost function now? Sir, what is this cost function now? So cost function is nothing, but we can say, we will denote this cost function with the help of j. Okay, j m comma c, we will say. Okay, so the cost function is nothing but summation of I equal to 1 to m, 1 by 2m in the bracket y hat I minus y of I whole square. This will be going our cost function. This will be going to be our cost function. Sir, I don't understand any of this. Sir, I don't know any of this. Okay, so let me just explain you. Starting from this m. Sir, what is this m over here? This m is the number of data points. Number of data points. Sir, what do you mean by data points? So when we have taken this example, we have 5 data points over here. Okay. So when we have seen this example, we have 5 data points over here. Okay. So this is how we can find the data points. Okay, sir. So the m over here represents the data points. Okay, sir. Sir, what is this y hat of I? Sir, what is this y hat of I? This y hat I is nothing but the predicted value. Sir, what do you mean by predicted value? The value that which we will be going to predict. Okay, based on some data, we are going to predict some kind of value, right? So this y hat is that predicted value. Okay, sir. So then what is this y of I? This y of I is the actual value. Suppose the actual value of the house is say 15,000, but the predicted value is 14,000. Okay, or let's say the predicted value is 17,000. The actual value is 15,000, but the predicted value is 17,000. So what we are going to do? We are simply going to subtract this. We will get the result as 2k. Then we will going to square this. That will give us 4. Okay, so we will get a 4. Then what we will do? We will sum up all these values. Okay, we will sum up all these values and divide it with 2m. Sir, I got it a little bit. I understood a little bit. But sir, can you give us an example? Sure. Let's just take one more example. Let's just take an example. Okay, sir. Suppose I have okay, so this is my equation of line first of all. Okay, y equal to mx plus c. Okay, sir. This is our equation of line. So what is our cost function? So what is our cost function? Cost function is j of m comma c is equal to summation of, I will take 1 by 2m outside. Okay, 1 by 2m summation of I equal to 1 to m y hat of I minus y of I whole square. Okay, sir. This is our cost function. Okay, sir. Now what will I do? I will take a graph. Okay, sir. In the x-axis, I have x, and in the y, this is the y-axis. Okay. Okay, sir. This is a graph. Now consider I'm taking the intercept as, suppose I'm going to choose 3 points. Okay, I will be taking 1, 1, 2, 2, 3, 3. I am going to plot these points on this graph. Okay, sir. This is 1, this is 2, this is 3. Again, this is 1, this is 2, this is 3. So we are going to plot 1, comma 1, 2, comma 2, 3, comma 3. Sir, it will lie somewhat here. It will lie somewhat here. And again, it will lie somewhat here. Okay, sir. Okay, sir, this is clear. Now, sir, what is the next step? So let me just these these are the points I have taken random. Okay, now what will I do? I will try to find a best fit line over here. Okay, how can I find the best fit line? Suppose I am taking right now C as 0. Okay, I am in this case. Hello guys, am I visible now? Hello guys, am I visible now? So maybe it was some kind of glitch. Okay, we'll just start. Okay, let me just share my screen quickly. Great. So my screen is visible, guys. Is my screen visible, guys? Great. So my screen is also visible. So let's continue. So we were here right now. Okay. Yes. So yes, sir. Let me just repeat it once again. We have taken some random data points. Okay. 1, comma 1, 2, comma 2, 3, comma 3. Okay, sir. Now I have plotted these random data points on our graph. Okay, sir. Now, sir, I have to create a best fit line using this equation. Okay, sir. Sir, how can I create a best fit line? Suppose in this case, I have taken C is equal to 0. Okay. I have taken C is equal to 0. Okay, sir. Now the equation will be y equal to mx. Okay, sir. Let me just take the value. Sir, how can I find the equation? How can I find the best fit line now? I will say let's just do a hit and trial. Okay. So in the hit and trial, I will take if m is equal to, let's say 1, I will start with 1. Okay. Okay, sir. So I will start with 1. So when we will take m is equal to 1, I will get the value as, I will get a line. When I will take m is equal to 1, I will get this line. You can check, okay. When I am going to take m is equal to 1, then y is equal to x. So I will get a line like this. Okay, sir. Okay, sir. Totally got this. Sir, if we are taking m is equal to 1 and c is equal to 0, then what will be the cost function? Sir, if we are taking m is equal to 1 and c is equal to 0, then what will be the cost function over here? So the cost function, I'm also going to draw a graph for cost function. Okay. So this graph will be for cost function. In this, I will take this c and m. Okay, sorry, m comma c. Sorry, m over here. Okay, sir. So I will take some values like 0 0.5, 1, 1.5, 2, 2.5, and on the y-axis I will take 1, 2, 3, 4, and 5. Okay, sir. Sir, if we have c is equal to 0 and we have m is equal to 1, what will be our cost function? Okay, so first of all, guys, don't confuse this m over here with this m. Okay, I'm going to take, instead of m, I'm going to take it as n. Okay, so this m and this n is totally different. Okay, don't confuse this. Okay, I'm going to take this as n. So this n over here is the number of data points. What are the number of data points? We have 3 data points. Okay, so the number of data points, or we can say n is equal to 3. Okay, sir. Sir, what will be the cost function then? The cost function will be 1 by 2n. N is equal to 6. N is equal to 3. Okay, so 1 by 2 into 3 summation of I equal to 1, 2, 3. I will have y hat minus yi. So as you can see in this case, there is no difference between the predicted value and the actual value, right? The best fit line covers all of the 3 points, right? The best fit line over here covers all of the 3 points. So there is no difference. Okay. So the y hat minus yi for my first point will be 0, second will be 0, and third will be 0. So I will have 0 plus 0 plus 0. Okay. Because there is no difference between any of the points. Okay, sir. Sir, so the answer will be 0. So when m is equal to 1, my j m comma c is equal to 0. Okay. When m is equal to 1, my j m comma c is 0. Okay. So the point will be plotted here. Okay, sir. So let's take another value. Say if m is equal to, let me just take 0.5. Okay. So if I will take m is equal to 0.5, I will have y equal to 1 by 2x. Okay. So if y is 1, I will have x is equal to 0.5. I will have x is equal to 0.5 somewhat here. If y is 2, I will have x is equal to 1 somewhat here. And if y is 3, I will have 1.5. So my next line will be like this. Okay. My next line will be like this. If I'm taking m is equal to 0.5, my line will be like this. Is this clear, guys? If I am taking m as 0.5, my line will be like this. Now in this case, I am going to have some error. So these are my errors. Okay. Okay, sir, these are the errors. Sir, what if we try to find the cost function in the case of m is equal to 0.5? So the cost function will be 1 upon 6. Sir, how do we get this 6? 2 into 3, we got the 6. Okay, sir. Now we have to sum up the errors. Sir, what are the errors? In the first case, over here, we can see the error is 0.5, right? We can see the error is 0.5. Okay. So we will take 0.5 square. So why square? Because it is written square over here in the formula. Okay. So we will take square. Okay, so 0.5 square. Okay, sir. In the second case, in the second case, in the second case, my error is of 1. Okay. So my point is lying on 1 and the error actual value is 2. So my error is 1. So I will take 1 square. Okay, sir. In the third case over here, my error is 1.5. Okay. The predicted value is 1.5, but the actual value is 3 over here. So my error is 1.5. Okay, sir. So I will take 1.5 whole square. So if I will calculate this quickly, this will be approximately equal to 0.58. Okay, sir, we got to know that when m is equal to 0.5, our j m comma c is equal to 0.5. Let's quickly plot this. When m is 0.5, our j is 0.58. So it will lie approximately over here. Okay, so it will lie approximately over here. Okay, sir. Till now everything is clear, guys. Till now everything is clear, guys. Like, how are we, with the help of the best fit line, how are we plotting the cost function? Is this clear? Great. Sir, can you take one more example? Sure. This time let's take if m is equal to 0. Okay. If m is equal to 0, sir, m is equal to 0, we will get a line like this. Oh, sorry. Sir, m is equal to 0, we will get a line like this. So this will be our line. Okay, sir. Okay, sir. This will be a line. Sir, how to plot the cost function now? So I will take 1 by 6. I will take all the errors now. Sir, what is the error in the first case? So this will be my error. The error is 1 because the predicted value is 0, but the actual value is 1. So the error is 1. Okay, sir. I will take 1 square plus. Sir, what is the error in second case? The error over here is 2. Okay, sir. I will quickly take 2 square. Okay, sir. Sir, for the next case, what is the error? The error over here is 3. Okay, sir. I will take 3 square. So if I will calculate this, this will be approximately equal to 2.3. Okay, sir. So if my value of m is 0, my j of m comma c will be 2.3. Okay, sir. Let's plot this on cost function graph. So if my m is 0, my j m comma c will be 2.3. That is somewhat over here. Okay, sir. So if you will take continuous points, like take the value of m as 2 or 2.5, 3, 3.5, 4 in negative, anything, okay. Change the value of m and plot the cost function. At the end of the cost function, you will get a graph somewhat like this. Okay. At the end of the cost function, when you plot more than 2 or 3 values, you will get a graph like this. Is this clear, guys? You will get a graph somewhat like this. What is this, sir? This graph over here, we call it gradient descent. This graph over here, we call it gradient descent. Is this clear, guys? If this is clear, write clear in the chat. If this is clear, write clear in the chat, guys, quickly. Because this is a very important thing. Great. So this much is clear. Great. Amazing. It's amazing. Okay, sir. So we have seen how can we plot the graph. Now what we have to do? We have to try to reach this global minima over here. Or we always try to, oh sorry, just a second. We always try to, so this is our gradient descent. Okay, sir. What we try to achieve, we always try to achieve this global minima over here. Okay, we always try to reach as close as to this global minima. Okay, we always try to reach, okay, I'm just going to mention this global minima. Okay, global minima, we always try to reach as close as to this global minima. Is this clear, guys? Is this clear, guys? Great. So this much is clear. Okay, sir. We always try to reach the global minima. Great. Sir, how do we reach the global minima now? Sir, how do we reach the global minima now? We try to reach the global minima with the help of repeat convergence theorem. Sir, what is this repeat convergence theorem now? Okay, let me just explain you this. Sir, what is this repeat convergence theorem? The repeat convergence theorem says that theta of I, theta of j, let's say j, okay, theta of j is equal to theta of j minus alpha partial derivative. Okay, this is partial derivative. Okay, theta of j theta of j. Sir, what does this mean over here now? Sir, what is this repeat convergence theorem? So this partial derivative thing, first of all, this partial derivative thing over here is nothing but the slope. Okay, this partial derivative thing over here is nothing but the slope of each and every point in this gradient descent. Okay, this partial derivative thing is nothing but the slope on this gradient descent. Okay, sir. Sir, what is this alpha over here? This alpha is nothing but the learning rate. Sir, what do you mean by learning rate? Learning rate is the rate through which we can say our model learns. I will explain this in detail in later on. Okay. So right now, first of all, sir, this slope over here, you told us that this partial derivative thing is the slope of gradient descent. Okay, sir. Suppose I am considering a point over here. I am considering a point over here. So the slope of this point, will be positive. Okay, the slope of this point will be positive. Okay, sir. Sir, the point you are considered right now is this one, and the slope will be positive. Okay, sir. So this value will be positive. Okay, sir. Which means a positive value. When alpha will be multiplied, it will still remain positive. Okay, sir. Which means a positive value is subtracted from Qj. Qj is nothing but this point. Okay. Qj is nothing but this point. Okay. So what we are doing, we are subtracting some positive value from Qj, which means we are subtracting some positive value from Qj, which means we will move towards left. Okay, which means we will move towards left. Okay, sir. So now let's suppose my value, suppose I am taking a point on the right side. Okay, I am taking a point on the right side. So this point on, sorry, on the left side. Okay, so this point in the left side, the value of the slope will be negative. Okay, so the slope value in the left side will be negative. Okay, sir. So when the value of slope is negative, so this whole value will also become negative. Okay, sir. This whole value will become negative. So what are we going to do? Negative negative becomes positive. So we are going to add something to Qj. Okay. When the value is negative, we will add something. Okay. Okay, sir. So we have seen the values of the slope is negative. So we are going to add something. That means the point will move in the right side. Similarly, again and again it will move to, if the point is on the right, it will move again and again to the left. If the point is on the left, it will again and again move towards the right. And this is how we try to reach the global minima. Is this clear, guys? How do we try to reach the global minima? Like, how do we use this repeat convergence theorem? Like, when the slope is positive, we will move towards the left in the gradient descent. When the slope is negative, we will move towards right in the gradient descent. And we will try to reach the global minima. If till now everything is clear, write clear in the chat quickly, guys. If everything is clear, write clear in the chat. Yes, it's used for functions. Okay. So yes, most of the things are clear. So we have seen that if the slope is positive, we will move towards left. If the slope is negative, we will move towards right. So this is how we try to reach towards global minima. Is this clear, guys? Is this clear, guys? So this is the complete mathematical intuition behind the linear regression. So this is the complete mathematical intuition behind the linear regression. Okay. Great, great. So in tomorrow's lecture, what we are going to do, we are going to implement linear regression on our model or on our data set, we can say. The attendance link will be shared soon, so please don't spam, guys, okay? Okay, so let's just quickly revise the session, okay? Let's just quickly go through, because some of you guys are saying that everything is clear, but like for a better understanding, let's just go and quickly let's just quickly revise everything, okay? So very first thing, we are going to see the linear regression part, okay? This linear regression is linear means straight, and regression when we have to predict a continuous value, okay? Okay, sir. What is the aim? The aim is to find the best fit line with minimal residual error. Okay, sir. Sir, what is the residual error? This blue line over here is called the residual error. Okay. Okay, sir. Then, sir, what is the equation of line? We have seen the equation of line is y equal to mx plus c. In this, m is the slope, x is the input value, c is the intercept, and y is the predicted value. Okay, sir. Then we have seen some examples of, like, when we put c is equal to 1.5 and m is equal to 0, this will be the line. And in the similar case, when we take c is equal to 0 and m is equal to 0.5, this will be the case. Okay, sir. Then we have seen some details on the cost function, like what is the formula for cost function and how to implement the best fit line. Okay, sir. Then we have seen how can we make the gradient descent with the help of the best fit line. Okay, sir. Like we have taken many values, that m is equal to 1, m is equal to 2, m is equal to 0.5 and 0. And we have seen how can we plot this cost function over here. Okay, sir. Then with the help of this repeat convergence theorem, with this formula, we saw how can we try to reach the global minima. Okay, sir. So this is the whole mathematical intuition behind linear regression. And in tomorrow's session, we will be going to see the practical implementation of this linear regression part. So the attendance link is in the description, is in the live chat. So you guys can go and fill out today's attendance. Okay. So yes, so this is it for today, guys. Just quickly fill out the attendance form in the live chat. The notes and the everything notes and will be provided in the WhatsApp group community. Okay, you guys can go and check the WhatsApp group community. You will find all the notes and everything. Okay. If there is any kind of assignment, it will be told to you guys. Okay, the project we will be starting in tomorrow's session. In the day 4 and day 5, we will be doing the project. Okay, this is it for today, guys. Thanks a lot for joining today's session, and we'll meet tomorrow. And we will cover the practical implementation of this linear regression. Okay, tomorrow same time, that is 7 o'clock. Thanks a lot for joining today's session, guys. Great. Thanks a lot for joining today, guys. The project we will do in day 4 and day 5. Okay, just leave the project to me. Just fill out the attendance of day 3, day 4 and day 5. I will see for day 2. Okay, the notes are there in the group description. Thanks a lot, guys, for joining today's session. Thank you. We'll meet tomorrow at the same time, that is 7 o'clock.